Meanwhile, I will quickly go through what I have covered yesterday or till date. I will quickly cover that in 1 minute only. So we have talked about, in terms of mechanics, we have talked about mechanics of rigid bodies and mechanics of deformable bodies. So each one of you know the difference between rigid and deformable body, or should I explain?
Yes, sir.
Yes, sir.
So in deformable bodies, you have two kinds of materials. One is called solid and other is called fluid. So in deformable bodies, you can treat solids as well as fluids as if they are deforming. For instance, any 2 points or any point, the relative distance between any 2 points will, if it changes, it is called deformable. If it does not change, then it is called rigid body. And fluid mechanics is one such case in which the deformable body happens to be fluid, that is either liquid or gas. And we noted that whether it is rigid body or deformable body, all mechanics could be actually defined in terms of statics, dynamics, kinematics, and constitutive relationships. So static means you are studying the motion of rigid body or deformable body when it is at rest or moving in constant velocity. Dynamics is called the cause, that is why that kind of trajectory or motion of the body is happening. And kinematics is that geometry itself, and constitutive relationship is the relationship between dynamics is equal to material property into kinematics. So for instance, we have already noted that force was equal to mass into acceleration. So if a body was thrown from a height with some initial velocity v, the trajectory was due to this force F, that was mg here, and due to initial velocity v. So studying this force mg and the initial velocity v is called dynamics. Studying the trajectory or the first or second order derivative of this trajectory, that is acceleration in this case, gives you kinematics. So this part is kinematics. And mass was the material property. This was the case of rigid body. Likewise, we can have for deformable body as well as in case of heat transfer. So this was the common thread, that all kind of physical laws, they are governed by some kind of constitutive relationship, and that constitutive relationship means the relationship between dynamics and kinematics through a material property. In case of force equal to mass into acceleration, force is the dynamic part, acceleration is the kinematics part, and mass is the material property. Any doubts to anyone? Now I am moving to today's lecture. I have given a brief overview of what we have covered yesterday. Now I am covering what is called fluid or material properties. Now, let me know, I have asked this question to you: do individual atoms have color? Quickly, do individual atoms have color?
No, sir.
No, sir.
So if I have one carbon atom, say one gold atom, can you recognize their color?
No, sir.
No.
No, sir.
So when can you recognize that carbon is say black and gold is say deep yellow? How can you, at what level can you say that?
Sir, when they are in bulk.
When they are in bulk. So those properties which are not present when those are individually present, but they are present when they are in bulk, those are called emergent properties. And this is interesting, that what is the minimum number of atoms that should come together to give an emergent property. So that I leave it as an open question. You can find out that, but there is no clearly defined answer to it. In certain cases, there are few numbers. In certain cases, there are more number of atoms. When they come together, then you can only assign a property that is called emergent property. And color is one of those. Any doubts?
Excuse me, sir.
हाँ जी.
सर ऐसा नहीं हो सकता कि लाइट के वेवलेंथ से ज्यादा नंबर ऑफ एटम्स हुए, मतलब
हाँ.
वेवलेंथ की विड्थ से ज्यादा नंबर ऑफ एटम्स हुए तो वो कलर शो करेगा.
So you are fairly accurate. So if the incident wavelength, say wavelength is say 200 nanometer, and the size of that group is of the order of 200 nanometer, then you will essentially be able to detect that. But color is from which wavelength to which wavelength? 400 to
800.
800 nanometer. What
800.
does that tell you? To find out color of anything, you at least require minimum size to be
400 nanometer.
400 nanometer. Is that clear?
Yes, sir.
So when atoms aggregate, the group size should be at least 400 nanometer, or more accurately 380 nanometer, so that you can detect its color. Any doubts?
No, sir.
Likewise, if I ask you, each one of you have seen water.
Yes, sir.
So can you say that, say I have one molecule of H2O, and I ask you what is the state of this? What will be your answer? Can you define state or phase of an individual molecule?
No, sir.
No, sir.
So again, this is an emergent property that is displayed if you have sufficiently large number of aggregates of those molecules. Then under similar conditions, under different operating conditions, say this was one molecule of water, this was second molecule, this was third, fourth, fifth, sixth, and so on. So they are, say, aggregates of water molecules. Say under certain conditions of temperature and pressure, they will behave like liquids, or that is water as such. Under certain condition, it will behave like a solid, that is ice. Under certain condition, it will behave like a gas. It depends all on external conditions. Although the interacting forces have not changed, so that should be clear. But the external conditions have actually led to definition of a phase. Is that clear?
Yes, sir.
Due to different temperature and pressure, these molecular distances can actually change, and that's why the phase changes. Is that clear?
Yes, sir.
Any doubts?
No, sir. No, sir.
So in terms of molecular state, you are conversant from this structure and from your 11th and 12th classes. I will be going little bit into more detail so that You understand what is pressure, what is temperature, and all that stuff. So in case of solids, you have this periodic structure. So various elements or various constituent atoms or molecules, they are not moving relative to each other. There is only a vibrational form of movement. They may be vibrating in this direction, or in a direction perpendicular to the plane of the screen. So in case of solids, only vibrational mode of energy is there. In case of liquids, there is vibrational, translational, as well as rotational. For instance, you know that water molecule is somewhat like this. So when you apply some kind of field, because this is polar molecule, it can actually rotate as well. The molecule itself can move somewhere. So please remember, in liquids, individual molecules do not move. Group of molecules can move. So when I say translation, it means translation of this group, because individual molecules cannot translate as such, because force of attraction is high here as compared to gas. Rotation means it can rotate about certain axis, this particular molecule itself or the group of molecules. And vibration, as it was in case of solid, here vibration can also be there. Now in case of gases, because there is sufficiently large distance between adjacent molecules, so there can be vibrational, translation, and rotational motion for each molecule as well. So this will help you to appreciate how to measure pressure in all the three cases. In case of solids, you only have vibrational mode. In case of liquids, you have vibrational, translation, and rotational mode. And in case of gases, you have all the three modes for individual molecules as well. Any doubts?
No, sir.
Now that was on molecular scale, but
Sir.
we engineers want something that is visible to our eyes. That is, we are much more interested in macroscopic properties, because ultimately you cannot measure those microscopic properties with your visible eyes or your senses. So macroscopic properties, also called bulk properties, can be broadly classified as intensive or extensive. So what are intensive properties? What are intensive properties?
That are independent of mass.
Independent of mass.
They don't depend on mass.
Okay. So say m was the mass of entire object. So this is, say, so can I write this like this? M should be equal to what? M1 plus M2 plus M3 plus M4. Any doubts? Any doubts?
No, sir.
No,
So
sir.
mass is what?
Extensive property.
Extensive property. What about volume? Can I write
It is
like this?
extensive. Yes, sir.
What about temperature?
No. It's
So
an intensive.
so please remember, T is not equal to T1 plus T2 plus T3 plus T4. So please remember, this is not equal to this. So whether you measure temperature here, if all the other conditions are same, so that should be kept in mind. while going from this configuration to this configuration, if there are no changes and there's everything uniformly distributed, then you cannot have this equal to this. So T will not be equal to T1 plus T2 plus T3 plus T4. Alternatively, it should be equal to T1, T should be equal to T1, should be equal to T2, should be equal to T3, should be equal to T4. Any doubts?
सर टेम्परेचर का दोबारा बता दीजिए सर एक बार बस.
Temperature means, for instance, आपके पास एक कमरा था एक, say you have divided this room through partitions. Initially you were measuring temperature of this room, say it was T. After you have partitioned this room into 4 sections, you again measure the temperatures of all the 4 sections. If nothing has changed while making these partitions, that I'm neglecting that some energy must have been spent, but I'm assuming that the configuration remains the same. Only thing I have done is I have partitioned these originally big room into 4 sections. Then temperature of each section will also be the same because I haven't changed anything. Temperature does not depend on the quantity. It is same everywhere. Are you clear है?
Yes sir.
सर
हाँ जी.
सर इंटेंसिव प्रॉपर्टीज वही होती है ना जो नंबर ऑफ पार्टिकल्स पे डिपेंड ना करे.
लेकिन that is little bit ambiguous. That's why I haven't spelled out that definition. For instance, if I ask you, आपने सबने have a bicycle with you?
यस सर.
Yes sir.
तो बाइसिकल में जब आप हवा भरवाते हैं तो have you seen a compressor in the shop?
Yes sir.
So compressor,
Yes, sir.
what kind of compressor is this? Reciprocating compressor? What does that mean? Air will be compressed in this compressor and you will get some pressure here. That is shown by this pressure gauge. Are you clear?
Yes sir.
Now the volume is same. If I keep on pumping air into this, now let me know, will the pressure change or not?
Sir, it will change.
It will change. Yes. So what does that tell you? Pressure is intensive or extensive property? In that sense, what you are asking?
Extensive. Sir, extensive property is a pressure sir.
So please remember, you should not remember intensive and extensive property like this, because pressure is actually intensive property. P is equal to P1 is equal to P2 is equal to P3 is equal to P4. So please remember, your definition of intensive property is incorrect, what you are saying. To define intensive property, the only thing you need to take care of is, if you have some property defined in a domain, simply go to the domain, divide the domain, and then try to find out that property in those subdomains. That is the only way you define intensive and extensive properties. Because if you define intensive properties that it is independent of number and all that stuff, you will land up in incorrect definition of intensive properties. Is that correct?
सर मतलब कि सर अगर डोमेन में अगर मतलब सर मान लो एग्जांपल मास है मान लो सर, तो अगर हम उस मास के डोमेन के सब डोमेन कर दिए 4,
हाँ,
तो अगर वो मतलब चारों का मास अगर अलग अलग होता है तो वो एक्सटेंसिव कहलाएगा, अगर सेम
अगर
रहता
वो
है तो
अलग अलग होके और उसके इक्वल होता है पहले वाले। ये देखो, ये आप देख रहे हो?
यस सर, यस सर।
मास ऑफ दिस कंप्लीट सिस्टम इज इक्वल टू मास ऑफ सब डोमेन. Volume of this complete system is equal to volume of subdomains. But this does not apply to temperature or pressure. That's why temperature and pressure, they are intensive properties, not extensive properties. हाँ जी, क्लियर है?
यस सर क्लियर है।
क्योंकि अगर आप डेंसिटी को भी देखिए, ट्राई टू सी डेंसिटी। से आई हैव अ कंटेनर हेयर, आई हैव से 100 molecules here. I have again same volume container, I have 1000 molecules. Now density of both of them will be same or different?
Same.
What is density?
Mass by volume.
Mass by volume. So in which volume is same, in which case is the mass higher?
First one.
1000 वाले में?
Yes, sir.
Yes, sir.
So again, please, this is not the definition how it should be defined. Here again, now try to see rho. Say this was rho. Now this was, now rho should be equal to what? Rho 1 should be equal to rho 2, should be equal to rho 3, should be equal to rho 4. So if you go by this definition of intensive and extensive properties, you will never land in incorrect interpretation. Otherwise, any kind of alternative definition will lead to incorrect inferences. So density is also an intensive property, although if you try to explain in this fashion, then density comes out to be an extensive property. That is incorrect. Is that clear?
Yes, sir.
Any doubts? So mass is an extensive property, volume is extensive, temperature is intensive, pressure is intensive, and density is intensive. Any doubts to anyone?
No, sir.